Currently, we're heading into quite an intense period in the project, and dynamic testing by far is some of the most complex testing that you can run. During dynamic testing, we're using the train as our test tool. These days, systems are so much more integrated. So the idea of, and I think it's potentially overlooked by people, when they get on a train, just how much goes into making sure that train stops accurately, that it pushes the right signals to the correct customer information display so that they're told how many minutes they have until their train arrives, so that they know when a delay is happening, and a whole heap of things. So it is incredibly complex. So ideally what we'd be going for is this approach of you don't wait for your dessert to come out before you start your entree or your mains, right? So as the tunnel becomes more mature and we get more systems that are at a higher level of functionality, we aim to test those functionalities. The testing that we have to do in the tunnel is kind of bundled up into sort of these high level categories. As an overarching kind of theme, you have infrastructure tests. So within the tunnel, we have new rigid overhead conductor bars rather than the overhead lines that you have on the rest of the network. We've got the PSDs. We then look at testing the signaling system because it becomes available in a more advanced state at that stage. And then we start integrating more and more systems as they come online. The end goal being that at the end of the program, we have most of the systems we need to run a service, a train pulling into a station, it docks correctly, the passenger alarms tell you what station you've come up to, the next station downstream tells you how many minutes you have until the next train arrives, things like that. So it's building up to that eventual integration test, which is that end-to-end holistic sort of system test. The majority of the testing will happen within the 9-kilometre tunnel. The new Arden station facilities are going to house the test crews while we're actually running the dynamic testing. So we're putting together like a temporary facility for the drivers to be housed there. Myself and a few of the other sort of dynamic testing management staff are going to be within a thing called the war room, which is going to exist within the station equipment room there. When we're testing in the tunnel, we essentially operate as an isolated state, and no one can come in, no one can come out, and what that allows us to do is run during the day. The tests themselves aren't particularly difficult, and in isolation, on a test track in the middle of a field somewhere, we could easily run these things. Where it's going to be difficult is trying to organise the testing around the organisation and logistics that are required to get those tests in place. So with the rigid overhead conductor bar as an example, we bring a train in from Pakenham. We have to bring that in on a thing called an ALBF, an after last before first. So it follows the last train as it goes down the line. We then have to bring it into the tunnel, and it's locked in there now. That's it. It's in that tunnel on that bore for 7, 14, 21 days, depending on how long we need it for. And then we need to flip it from one line to the other line. The tunnel itself has no way of doing that. So you're going to have to bring it out of the tunnel again and back in, and organising when you get that occupation, how you make sure you get that done in this period of time at night so that you don't affect the passenger service during the day. Tests themselves, we can't predict what gremlins are going to come out of the software, but it's more the organisation and the logistics that are going to be the challenge on this.